So good afternoon everyone. Now we're going to talk about the last part of chapter 3, where we're going to look at what we call the onshore and offshore initial gas processing. And this normally be done at the wellhead, where you're going to do minimum purification or minimum treatment to remove a small fraction of H2O, CO2, H2S and some impurities as well. And normally what you're going to start first with what we call the water gas removal, or what we call the liquid gas separator, where you're going to collect the water or remove the water from the gas stream, and then based on the amount of water that you have left in the system or the gas stream, and based on the temperature and based on the pressure drop that you have, you will decide what kind of chemical you're going to inject to do what we call the prevention of a hydrate formation. You're going to inject, for example, methanol or glycol, and we're going to look at certain scenarios where glycol is more preferable to be used once compared to methanol. And then you will recover the glycol or methanol and then reuse it again. The gas will be then cooled to reduce the temperature to a freezing point, also to remove further of water that's not being removed by the chemical treatment, and also the heavy hydrocarbon also can be removed partially in the knockout drum sometimes. On the other hand, when we talk about the offshore gas processing, which is going to take part, or where the reservoir is located in the sea, the processing will be done normally in the subsea or the platform or onboard platform, where you're going to remove part of the carbon dioxide, or you're going to remove majority of part of the CO2, H2O, acid gases such as H2S as well, and you're going to produce sometimes dry gas, and then you will use pump, and this pump will pump the sweet natural gas to the offshore via submarine pipeline. You will require also what we call the compression station, and these compression stations is also important to increase the pressure of the gas in the pipeline as well, till it reaches to the shore, or to the main processing, or to the main natural gas plant that's located on land. And normally once you remove the CO2 and the water from the gas in the field, which means that this processing is done in the field, on the offshore gas processing, you will use this CO2 or the removed CO2 and the water will be re-injected in the gas field to provide again a pressure, or to increase the pressure of the reservoir to get more of the gas. But the details of this process, this is something out of the scope of this course. This is just like an overview of what's been done in terms of offshore and offshore gas processing. And here again we are talking about the gas processing that's done in the field itself. Now for gas transportation, or what we call the pipeline gas transportation, how do we transport the gas from the production field to the processing field? Now when we talk about offshore gas field, or offshore, for example, production field, normally the processing field, or the processing plant will be located onshore. And in this case, or in this scenario, when you have, or when you are dealing with what we call the offshore reservoir or the offshore field, you will connect, or what we call several wells or several reservoirs will be connected to a specific platform, and then it will be, or the gas will be then pumped from that platform to the offshore gas processing plant. And you will use like small pipelines or small lines in diameter and lengths. You can find these pipelines sometimes subsea, sometimes above the ground, sometimes buried in the ground. If you have, like, normally large pipeline will be normally buried underground, will be always. The above ground is always good to have it. It's easy to maintain, but it will suffer from several things, or suffer from the weather condition. It will suffer from corrosion, from several things. Sometimes it might have cracks in the pipes. That's why you need what we call the mechanical support for these pipes. And that's why, like, maintaining, or the maintenance of the above ground lines or pipelines is easier than the buried one. But again, the above ground one will suffer more from the weather condition once compared to the buried one. And here we have something called the heat pipes, which is like a common technique used in, for example, in supporting, or as a way to protect the pipeline. And in this video you can see how what do you mean by the heat pipes, or how heat pipes technology work in oil and gas industry, specifically in gas industry. Now you will normally also require, or you will be needing what we call the drip system, where the drip system will be used to emptify or remove part of the liquids that sometimes accumulated inside the pipe. And as a well-known phenomena that as the pressure of the reservoir decrease, the pressure in the pipeline also will be reduced, which means that the amount of gas that you are producing is less than the one when you have like high pressure reservoir, or the reservoir is maintained at high pressure. And normally the sub-ambient pressure is highly problematic, which means that you will require what we call like specific operation for these like below ambient pressure, and this is very challenging for you to do, for example for the industry. And the presence of air also in the pipeline is also undesirable. It's not favorable because it will cause like the flow of the air with the gas inside. This is going to be causing a lot of problem as well. The oxygen also intake is also non-preferable because you will oxidize part of the material and you will enhance the corrosion as well, and you will the oxygen or the air in general will react with certain component of the gas stream. You in these pipelines normally you will have certain technology. You will have what we call, you can sometimes use certain sensors or certain technique in order to predict or to detect exactly where the leaks coming from in the pipeline, which is something that's not easily be done. And you have what we call the SCADA, which is the supervisory control and data acquisition technique used to manage the pipeline flow and control, where you're gonna predict, for example, if there is any crack in the pipe or if there is any leak in the pipe, and this system will give you an idea or will give you an estimation where for example the crack of the pipe will take place. But normally you will use some other technique to predict where the crack in the pipe took place exactly, or the exact location of the crack in the pipe. Also in natural gas processing you will use what we call the bigging process, or you will need what we call the bigging process, where bigging process is considered to be like a cleaning and inspection process for the pipe. Cleaning for the pipe from the waxes, from for example the debris, from the impurities, from the solid material, for example. And sometimes also it's used for inspection the pipe, where you can detect or predict how much is the thickness of the pipe, for example. And you're going to use something called bigs. These are examples of the bigs, where these bigs will be launched using something called big launcher, where the big launcher is like a bullet. It will launch the bigs inside the pipes, and it will then start to clean the pipes or predict or do the inspection for the pipe. It can do several things. The bigs or the bigging process can do several services or several jobs or several duties. It can offer it as a barrier between different liquids products if you have it. It can inspect the wall thickness as we explained earlier, and detect where there is damage, for example in the pipe. It will clean the pipe from the dirt, waxes, debris, for example sand sometimes. And it will coat. It can be used also to coat the inner pipe with something, with the inhibitors, for example. And it can also be used to eliminate what we call the liquid phase, such as water and heavy hydrocarbons, in the case of in the case where you have like the two-phase flow. And normally, as you know, like when you have the two-phase flow, normally the liquid will flow in a velocity less than the gas, and the bigs will be made normally of polyurethane foam. And nowadays we can see what we have, what's called as the smart bigs. And this is again a process of how can the bigs, or this is like a description of how can bigs work, for example in the cleaning. But the main target in the cleaning and the pipe detection or pipe for example inspection. So the main target of bigging, which is also, you can see it in the video here, or the main purpose of doing what we call the pipe bigging is what we call two things: cleaning and inspection for the pipe. Cleaning for the pipe from the dirt, waxes and solid material impurities, and inspection for the pipe for the wall thickness. Inspection the pipe if it has, for example, cracks in the pipe. It can be also used to coat the inner side or the internal surface of the pipe with certain chemicals such as inhibitors, for example. And it can also be used to separate different liquid phases or different phases, for example the liquid from the gas, or different liquid products if you have it. Now we're going to talk about something called flow assurance, which is very important aspect or very important parameter that we need to look at when we operate, or when we for example transport the gas from the production to the processing, or even from the processing to the consumer. So flow assurance means that the flow of the gas will not be interrupted, or will not be, for example, stopped for certain reason. and we want to make sure that we avoid the condition that might contribute to the stopping of the flow of the natural gas, for example, in the pipeline. There are several things that we need to look at when we talk about flow assurance. The first thing we're going to talk about is the wax and asphaltene and the wax and asphaltene deposition, which is come actually from the once we extract the gas from the reservoir. Also, you have the scale, which is the inorganic material such as the salt, for example, NaCl, for example, MgCl2, for example. And the third one, which is the most challenging one, is the gas hydrate formation, which is the things that you can see here, which is looks like an ice in the pipe. So these are like the things that we need to consider, or we need to look at once we want to make sure, or we want to ensure the flow of the gas inside the pipe. For the waxes and asphaltene and even the scales, this can be done easily because the bigging will take care of this problem. Removal of waxes, removal of debris, removal of scales sometimes even. This can be done using the bigging technique that we have seen before in the previous slide. But for example, for the hydrate formation, there are several scenarios that might create or might provide the chances for the hydrate to formate. For example, and one of the major challenges for the hydrate formation, that the hydrate once it's formed, it will cause the blocking of the pipe. So which means that there will be no flow of the natural gas inside the pipe. And this is really hazardous because it will create a huge pressure drop inside the pipeline that you have. And one of the major challenges that for the hydrate formation, that it occurs within minutes. And the second thing, that there are certain conditions or certain circumstances that might contribute to the formation of the hydrate at certain conditions. For example, if you have upset in the pressure, if you have upset in the operation, for example, if you have failure in the separator, if you have failure in certain pumps or compressor, this might also provide a good chance for the hydrate to start forming. Normally the gas hydrate, we will talk about this in more details in the next few chapters, but normally the gas hydrate formation will be predicted using what we call the statistical thermodynamic. How do we avoid gas hydrate? We can do several things. You can operate outside gas hydrate region that we're gonna be seeing next lecture when we talk, next few chapters when we start talking about the hydrate formation. We will specify a range or a region in terms of pressure and temperature where we predict that based on this operation condition, if I operate in this zone, this means that I will have definitely what we call the hydrate formation. And if I operate outside this zone, then I will not have the chance to have the hydrate formation. And then the second method to avoid hydrate is what we call the dehydration, which means that we're going to remove some of the water. And the third one is what we call the chemical treatment, where we inject hydrate inhibitors such as methanol or ethylene glycol sometimes. And this is the chart that we're gonna see it, or what we call the hydrate formation chart. This is something that we're gonna discuss in details later on. So far, when we talk about natural gas processing, we cannot ignore the fact that when we deal with natural gas processing, you expect, or the process might involve certain environmental and safety issues. Some of these issues might include the leaks of certain gases, such as H2S, which is like poisonous gas, or even the leak of methane, which is flammable gases as well, or plugged of the pipes due to the formation of the hydrates, or due to the accumulation, for example, asphaltene or waxes, which might also result in explosion of the pipes, for example. Environmental concerns also might be a huge issue when you have, for example, a leak of gases, or even the some of the liquids or some of the heavy fraction that you have in the rivers, for example, on the sea. Methanol leaks as well, which might also cause a chance for a fire to start. The emission also, which is one major sources or one major problem with the natural gas processing, such as NOx and SOx, and CO2 as well, and CO as well. So these are a list of some environmental and safety issues that might also be predicted or expected once you deal with natural gas processing. Now let's talk a little bit about what we call the compressor station or the compression station, which is very important in natural gas transportation, because compression will be normally used to increase the pressure of the fluid inside the pipe, which means that you are increasing the pressure of the gas inside the pipe. And normally before the compressor, so if you look at this process flow diagram, before the compressor you will install something called the inlet scrubber, and the inlet scrubber will the input of the inlet scrubber will be the gas from the well. So you will first let the gas pass through what we call the inlet scrubber, where the inlet scrubber will collect or will remove the liquid from the gas through what we call liquid gas separation, for example. And the liquid will be collected or will be re-injected. If it's for example water, you can re-inject this water back to the reservoir. If it's like heavy hydrocarbon, you can collect this heavy hydrocarbon and use it as a product. And normally you will use something called booster station, where booster station will be required to increase the pressure or repressurize the gas and increase the pressure in the pipeline. And this is normally will be used in the range between 65 to 160 kilometer intervals. For example, if you have the extraction plant here, for example, and 250 kilometer away from the extraction or production plant, you have the processing plant. Okay, so which means that you need to ship or you need to transport the gas from the production plant to the processing plant. And this, as a result, if you pressurize this gas inside the pipeline and you allow the gas to flow inside the pipe, there will be certain pressure drop. So in order to maintain this pressure drop or in order to maintain the pressure of the fluid inside the pipe as high as possible, you need what we call the booster station, where the booster station will be pressure or will pressurize the gas inside the pipe and increase the pressure of the fluid inside the pipe. And as we explained several times, normally if you are dealing with two-phase flow, this is very complicated scenario, and this will complicate the process and will increase the risk of having certain upsets in the process or in the operation itself. So now we will talk about what we call the types of compressor station, or what kind of compressor station we can find in natural gas processing. The first type is what we call the field gas gathering. Let me just change the color. The first type is what we call the field gas gathering station, or these kind of compressor station will collect or will gather the gas from several wells, where these wells have like very low pressure or insufficient pressure for the production. So these station will generally handle the suction pressure or the low suction pressure coming from the reservoir or from the different wells or from different production wells. And the capacity of these gathering station will be in several millions of cubic feet per day. The second type is what we call the repressuring or recycling station, where the repressuring or recycling station will develop high pressure up to approximately 415 for processing purposes. And the third type will be what we call the relay or main line station, where it will boost the pressure in the transmission line to approximately between 14 to 90 bar. So you have like the gathering station, where the gathering station deal with pressure or low pressure at the suction coming from the different wells, and this will gather the station from different wells, and the pressure will be maintained at low, for example, or the suction pressure will be low relatively, and then the these gas gathering station can deal with several millions of cubic feet per day. The second type is what we call the relay or mainline station, which increase the pressure in the transmission line, and normally it will increase the pressure between 14 to 90 bar. The third one is what we call the repressuring or recycling station, which will also increase or will develop what we call the high pressure in the pipeline, and it will reach for up to approximately 415 bar. And this is required for normally processing, certain processing. Another two type is what we call the the storage field station, where the storage field station will compress natural gas from the trunk or from the main line for injecting in the wells, for example, or the storage wells, and the pressure will be approximately 275 bar or approximately 300 bar, for example. And the last one will be what we call the distribution gas compression station, which will pump gas from the storage area to the at high pressure to a relatively medium pressure of approximately 1.4 bar to and high pressure up to 7 bar. So you have to keep in mind that distribution gas compression station will deal or will work with the gas once the gas, for example, or will work on moving the gas from the storage area where the pressure is maintained at very high pressure, approximately 170 bar, to points where the pressure will be medium 1.4 bar to high pressure, which is around 7 bar. So these are the typical 5 types of compressor station that you can find in any natural gas processing plant. So normally when you select the type of compressor, you can select from mainly 2 types, which is the reciprocating types and the rotary types, and the selection process will be based on several things. It will be based on the capacity of the gas, how much of the gas you want to produce, for example, the life cycle cost, the size of the compressor that you are looking at, the efficiency and reliability, the capital expenditure, how much, for example, money you can invest in buying these compressor, for example, the running cost and the level of utilization, how frequent you're gonna use or utilize these compressor, for example. And normally, you know, like once you want to operate a compressor, you need what we call the driver, and the driver can be driven, or the driver for the compressor can be done through several forces. It can be done through what we call electrical motor that require electricity. It can be done through what we call the gas engine that's normally powered by the natural gas, and it can also done by what we call the gas turbine, which is also again operated by the natural gas. And we're gonna see what do we mean by these drivers, or what are the main components of the compressor in the next few slides. But we're gonna discuss it slightly or briefly, and we'll not really go into the details of the compressor component. Now we're gonna talk about the first type of compressor that we can use, is what we call the which is called the reciprocating compressor. This is something I think that you have seen before, maybe in terms of pumps as well, but the same principle. The reciprocating compressor is one of the most common compressor used in natural gas, or even in the industry in general. It's driven by gas engine. It can be driven by gas engine or electric motors, where the electric motors you need electricity. Gas engine mean you need natural gas to drive the shaft of the compressor, for example. It's flexible in pressure range and capacity. Normally it will reach, for example, or the pressure will be around or less than 415 bar, and it can also accommodate several or wide range of volumetric capacity. And normally it will deliver approximately 330,000 foot cube per minute, and the pressure will be approximately 10,000 psi. And this is the principle or the concept on how the reciprocating pump work. This is one type of the reciprocating pump, so that you can see how it works specifically. But for the purpose of this course, you don't need to memorize these numbers. You need just to know that reciprocating pump is one of the typical pumps, or sorry, reciprocating compressor is one of the most common compressor used in industry in general, and it can be operated by gas engine, or it can be driven, or the shaft of that, or it can be operated simply by gas engine or electric motors, for example, and it can accommodate wide range of operating pressure and volumetric flow rate. In this slide now we're going to discuss the second type of compressor that can also be used or found in the industry in general, which is the rotary compressor, where the rotary compressor can be classified into 2 types, which is centrifugal compressor and rotary blower. And this is one type of rotary compressor. As you can see, why they call it rotary, because the 2 screws are rotating. If you can see here, the 2 screws are rotating in opposite direction in order to deliver the fluid at specific pressure. And one common thing, or one main things, or common between the rotary compressor and the reciprocating compressor, is that both can be operated by gas turbines or electric motors. But in the case of the rotary compressor, you can adjust the design of the impeller or the size of the impeller to increase the gas velocity and static pressure that you want to obtain. One more thing to look at is what we call the diffuser, which is again one component or one major component of the rotary compressor, and the main target of the diffuser, or the main duty of the diffuser, is to convert momentum to static pressure. Now, once we compare both of them, you can find sometimes that the reciprocating pump has several advantages over the centrifugal one or the rotary one, and sometimes or in certain scenario, the reciprocating one or the centrifugal one or the rotary one will be more preferable to use, or it has more advantages to be used once compared to the reciprocating one. So, for example, if you look at the here is the list of the advantages of, for example, reciprocating one. It has it's ideal, for example, for low volume. It will give you a relatively good or high pressure, for example. It has high efficiency when you are dealing with high pressure system. It has relatively low cost. It's less sensitive as well. And once we get to the centrifugal compressor, which is again a rotary type, it's preferable because it's ideal for high volume once compared to the reciprocating. Reciprocating one is good for low volume. Centrifugal one or the rotary one is good for high volume. It has, for example, high efficiency over wide range of operating pressure. Meanwhile, the reciprocating one, it has high efficiency at only high pressure ratio. It has low maintenance cost. For example, the centrifugal compressor, it has or the rotary one it has low maintenance cost once compared to the reciprocating one. So these are list of the advantages and disadvantages, and again, you don't need to memorize all these points. All you need to know is that the basic two types of the compressor that can be found in the industry is the reciprocating type and how it works, and the centrifugal one or the rotary one and how it works. Some of them has advantage over the other. You need just to know one or two advantages, such as, for example, that the reciprocating one is good for low volume, the centrifugal one is good for high volume. The reciprocating one, for example, will have low capital cost. The centrifugal one will have low maintenance cost. So these are the or list of advantages and disadvantages of the major two types of the compressors that can be found in the industry. So by that we conclude chapter 3. So we are done now with chapter 3, and then starting from chapter 4, we'll start talking about the process of the natural gas processing. We'll start with the liquid removal or the liquid gas separator, and then we will move from one unit to another unit. And in each chapter, we'll discuss one specific unit or one specific system inside the natural gas plant.